First of all, thank you very much for you know to this group who have given me an opportunity to talk here in front of you. And today our topic is on GenAI, LLMs, and maybe we can also touch upon basics of what all security issues we have in GenAI and LLMs. Okay, and I am Jitendra. I am the co-founder of Detoxio AI. We are a startup based in Bangalore, and our area of specialty is GenAI, LLMs, and the security and safety of LLMs and GenAI applications. Okay. So we work like in the area of LLM red teaming, GenAI adversarial testing, app adversarial testing, security monitoring, and so on. Okay. So today our topic will be to cover basics of LLMs. 1 minute. Why it is coming like this? Basics of LLMs and the basics of LLMs, and we'll like to kind of start from ground zero, considering that we have a lot of enthusiasts who may be coming for the maybe first few times understanding LLMs, and this will also basically make a foundation of your understanding, because I believe fundamental understanding and foundation understanding of anything is important for a long journey, correct? Okay, so let me kind of start with basics first, and I want to ask also I want to make this session more interactive. So how many of you are in artificial intelligence, machine learning? Have you dealt with machine learning, deep learning before? I'm sure everyone might definitely have heard about it, but how many of you? So what is the fundamental difference of LLMs is from other machine learning models such as deep learning and machine learning and artificial intelligence? Anyone want to give quick, maybe anyone want to answer very quickly, like what is the fundamental difference between large language models? What difference does it make? Because machine learning is there for the last, I will tell you, last 60 years. Similar to the age of PC, we have machine learning. We have artificial intelligence. Anyone? Quickly? Yep. Yeah. It can understand human text and language. I think what Anirudh has said is the most fundamental thing, which even I'm finding it, as the basic foundational difference, that I'm sure everyone is using Chat GPT, and most of the time it is getting it right. When you ask a question, when you want to generate a code, when you want to analyze, a reason, even performing any reasoning on top of giving it few documents, it can actually understand the English, not only English language, but human language that we are using right now. And not only human language, it can actually understand any structured language, including programming language such as C, Java. Every programming language it can understand, and also even write code uh, in that language, right? So GenAI and large language model overall is a subset of deep learning, something called deep learning, which is a subset of machine learning, and which is a subset of artificial intelligence. Okay, so you can think artificial intelligence is the big universe, and inside it, LLM and GenAI is a subpart of something called deep learning. And what deep learning is the ability of a program or a machine to learn from its mistakes, or to learn from examples. Okay, and so that next time it can perform the same task in a better way. Okay, so that is what is the basically is machine learning is. Now let me kind of go through to the next step. 1 minute. Yeah. And if you look at large language models actually have grown both in size and complexity for the last few years. I mean, everyone knows that the first language model came in 2017. Actually, I didn't know up to 2021. Okay, the OpenAI actually releases ChatGPT 1 in 2017, and ChatGPT 2, ChatGPT 3, and the number of parameters. Okay, so when I say number of parameters is like number of neurons. You can consider like how many number of neurons in my brain you can have. So that's the basic difference between ChatGPT 1 and ChatGPT 4. As you know already that the more number of neurons, the more intelligence it should have, ideally. Yeah, and that's actually true in general. May not be true exactly. So compared to 2017 in GPT-1, which had on 115 million parameters, you know, and each parameter is nothing but a number, one number, like floating point number. And up to now, which is ChatGPT 4 had 1 trillion parameters. So you can see that it has grown not just 100x, 1000x, but actually it has grown the million x probably from the last couple of years, 5 years, isn't it? So tremendous growth has happened in large language models for the last 5 years, and it is now going to empower probably every product. That's what I can see on a daily basis, once or other. So great opportunity, great thing to learn, and its evolution has also be one of the fastest in the world in the human history. Okay, so I will skip few things to make it short. Uh, so one thing you can always differentiate that today we talk Gen AI is a generative AI, right? Something called generative AI. But they were, apart from generative AI, in up to 2019, deep learning and machine learning, we already had something called predictive models. Okay, so these are nothing but neural networks that take the data, training data, and predict true false or predict it to be something. Like in this case, if you give pictures and ask it a model to find out what is the picture painted by Van Gogh. Van Gogh is a painter. Then probably it will tell you with the probability 0 and probability 1 which pictures uh, are painted by Van Gogh and which pictures are not painted by Van Gogh. Right. So this is something called predictive in nature. Like it is predicting yes or no. Okay, is kind of a prediction. Therefore, we call them prediction models because they predict. And the power of these models are, and I think all of us know these prediction models. Like we are using Google Photos, we are using text summarization. Google has already been using this machine learning for the last few decades now, right? And most of the work we see on mobile phones, most of the intelligent work we see on mobile phones actually is powered by discriminative, or we call it predictive models, and also very short, small, large language models like BERT, which took birth in 2014 kind of thing. So the BERT is one of the first model, probably is one of the, you can say it's the father of GPT. It has a different architecture, but it actually can summarize text. Given a whole paragraph, it could summarize text to some extent. Okay. So this is called predictive models, and I will not go through them because this is definitely will take us to a different direction. But I will tell you now there is something called generative models. Okay. So generative models, the idea is that it can not only, it does not predict like whether it's a horse or a dog, but actually it's given an image, it creates another form of an image. Like I have a mouth of a horse and I want to generate the full horse. Okay, it's a generation problem that I know horse, like partial picture of a horse, and I'll tell model, why don't you generate the full picture of the horse? And how it can do it, because it now understand its color, it understand is maybe a breed, it also understand, how the mouse, the face looks like there is a white color patch on the face and so on, right? So it can actually take this model, take this picture, and actually can go and generate a full, picture of a horse. And this is one of the very uh, simple example of large, generative, any kind of generative model. Okay, so what generative models do is they kind of generate data, generate a different form of the same picture or a text or a paragraph of a text, or even a voice. Okay, and the latest, GPT-2, but previously, we used to have GAN, generative adversarial networks. They are all generative models. So we are now entering into the world of generative models, right? Most all the models that you see right now today are actually generative models, and the power of generative model is that they can also predict. Rather than just generating horse, they can also say yes and no, and also then generate a horse picture, right? So they can do both prediction and generation at the same time. So that's the power of this thing. Okay. Now I'll just now, in order to quickly understand what LLMs are, can you read this story and try to complete this story? Just read it, 2 minutes, 1 minute maybe. I'm sure most of you can actually complete this. Yeah. Can you think of what will come next? Like, confident on his swift legs, the rabbit darted ahead soon, but complacent and decided to take a nap midway. And then you will go and complete the story. How did you do that? The reason is that you had a prologue. You had already had, because this story is already there in your knowledge base, right? It is already there in your knowledge. You have heard it before. But then I'm giving you a part of the initial text and then telling you to summarize, to kind of finish it. So what you're doing is you are going to your knowledge base. You're kind of matching, okay, this is my text, initial text, and then matching what should come next, and you start then generating this story, the next word in this story, isn't it? Like, I can always say, became complacent and decided to take a nap midway, and then slept under a tree. After half an hour or so, the tortoise came and passed by the rabbit. So I can keep on generating it, isn't it? So what essentially I'm doing is I'm doing some kind of next word prediction based on whatever text I already have, isn't it? So this is exactly what LLM do. In fact, what LLM do is they always try to generate the next word. They always try to predict the next word based on the previous word. Okay, and interestingly, if you see that your story is always, if I tell you to write this story in a document or in a Word document, most of your stories will be different from each other's stories, or the wording that you will use will be different. Okay, the reason is that most of us actually are predicting words in a different way, but overall story will look more or less similar, isn't it? In the same way, LLM also works in the similar way. They try to predict the next word, but because LLMs, if you look at two different LLMs, they will always produce the different text every time. And that's called, that's one of the basic fundamental issue with LLMs, that LLMs can produce different answers for the same question every time. They can actually create a something called hallucination. Everyone knows hallucinations, that they start with this story, but then they kind of, if they do not know anything about this story, if the story is not there in their knowledge base, they will actually cook up a new story which does not even exist. Okay, so they can say decided to take a nap midway, then a hunter came and kind of caught the rabbit, take it to his village, and something like this, right? So it can also hallucinate. That's because the knowledge it has may not contain the question that you are asking, or There may be other reasons. We will not go in that detail, but there may be other reasons, right? So this is what basically, LLMs are doing. They are doing next word prediction. So I'll probably quickly show you the architecture of a typical LLM, and then from there we will go to the some kind of how to run the LLM and so on. Yeah, any questions so far? Let me know. All good? Am I going too fast or too slow? Let me know. Okay, awesome. So far what we have done, we have kind of understood what LLMs are doing. Okay, uh, they are generating things, isn't it? Like if I now let's go a bit deeper inside LLMs and what is their architecture, like how does really work? How does this everything really work? Huh? Let's look at that. 1 minute. So if you look at LLMs, it has two components. One is encoder and one is decoder. So encoder and decoder. Hmm? And in order to understand this encoder decoder, actually, it's very. I will try to explain it in a very intuitive way, and then I will try to also probably do it. Okay. So if you look at this story again, let's come back to this story again. So when I presented you this story, partial story, what did you did the first when you read this story? Actually, you're not generating anything. You are just understanding this partial text and see what is happening. What is it about? Is it a story? Who are the characters? What is the sequence of events have happened so far, and so on? Correct. So that is that will happen during the first part of your task, which I'll give you, isn't it? You have already done. You definitely have done the same thing. You have understood it. So that's what exactly happens in encoder. So encoder is a component in a LLM that exactly do the similar thing. What it does, it break the text into something called tokens. So it will break like this whole thing into once upon a time in. So similar to our programming language, it will break everything into tokens. It will then these tokens then will be fed into some very complex network of neural networks, machine learning networks. And neural network is one of the main thing. And then it try to understand the sequence. It try to understand the character. It try to correlate things like what is rabbit, forest, tortoise. If I tell you forest, rabbit, tortoise, and race, most likely you will know what I'm talking about. Correct? Because it tells you the exact context what it is about, right? We all know this story, so just I'll tell you: forest, rabbit, tortoise, and a race, and you know what I'm talking about. Exactly in the similar way, there is something called self-attention in LLMs. Self-attention does exactly the same thing in a loose way, I'm saying, where it try to kind of correlate each other words with each other in a matrix and understand all of this context from it. And this is exactly what encoder does. So encoder understand. And okay, the role of decoder is simple. The role of decoder is from whatever we have done so far and the task that we have, the next thing is to generate the tokens. The token will be nothing but words. Tokens actually are more complex than words, but for right now, let's assume every token is one word. So decoder, based on the encoder, it will go and start generating these words. And if you look at it, the magic of LLMs is that once it starts generating words, the probability of any other word apart from steadily continued will be very low. The only word that make more sense once it has this much sentence it has generated will be like continued steadily and so on. So it's basically start generating this word, and that is done by decoder, right? So encoder, decoder, these are the two primary component of a LLM. Okay, and if you just go inside, just basically let's go a bit deeper. So what LLM generally is will have okay. So if you just go a bit deeper, this is the sequence of things that happens. Okay. Say I gave you an example. The input text is this is an example. This is the input of a text. The first thing what LLM does it actually break it down into small break it down into tokens, as we call it pre-processing step. So everything will be break it down into the whole sentence will be like this is a example. Will be break it down into tokens. Then there is a complex architecture of encoder, which is nothing but a layer of neural networks, a complex layer of neural networks. And the goal of this neural network is to do an understanding of this text and convert that into something called embedding. And embedding is nothing but a vector of numbers. Like every vector is you can consider is a sequence of numbers. 1, 2, 3, 4, 5, 6 is one vector. Because LLMs only understand numbers. They don't understand words, right? Just like in programming language, the computer just understand binary language. Okay, so we compile the program into binary language, isn't it? That's the job of a compiler. In the same way, the job of encoder is actually to take an text sentence and convert that into something called embeddings. That is similar to binary language. It's also kind of a binary language for decoder to work on. Okay, uh, embedding will come a bit later, but that's the analogy I want to give. And then this embedding goes to decoder, and then decoder actually start generating something called whatever text it has to generate. Okay, so this is a high level architecture of encoder and decoder. Now there are multiple architectures of LLMs. Okay, uh, initially when the first LLM came, like GPT-1, or before that like BERT, it used to have both encoder and decoder architecture. But over a period of time, people have started kind of creating multiple variants, like BERT only has encoder, nothing else. GPT only has a decoder architecture, nothing else. So you will see at various places decoder only architecture, or encoder architecture, or encoder decoder architecture, right? So that's how it will happen. Now I'll not go that deep, but I think do one thing. I'll probably this is probably we'll have another session on very deep understanding of everything. But what I want to show today is something else, which is like how to now run LLMs so that you can start playing with it. Okay. And probably next time when we will sit, we will also go through the fundamentals again. So far, I think you must definitely you have understanding of LLMs and what is their encoder decoder architecture, what encoder does, and so on, right? So the next step will be to now how to run these LLMs, right? That is the next question. The reason is that uh, in order to for a cybersecurity guys, right? There are multiple ways you can if you have to start looking into LLMs and their safety and security, you need to at least know how to run it so that you can do a LLM red teaming at some point in right. So that is the focus. That is a goal, maybe long run. So the first thing you need to do is to create an account on something called on Hugging Face. So how many of you have an account on Hugging Face, or do you have any account on Hugging Face? Any one of you? Yeah, I think some of you have an account. If you don't have it, yeah, if you don't have it, let's go and create an account. Just go and register. Okay, just go and register on Hugging Face. Second thing you need is an account on, and then if you look at Hugging Face, you will also get a lot of tutorials on how to run it and everything. Okay, so there is a quick start tour guide and everything. Okay, so we will. So that is one. Now, how to run these LLMs? How to run these LLMs, right? So one of the way, very basic way of to running this LLM is to first go to Hugging Face and search for an LLM. Like if I search for Meta Llama 2 billion parameters. Now I'll explain you, what this means. So every organization in Hugging Face has an account like Meta Llama. Okay. And Meta Llama then will release their, models, like this. So you can see that they have released so far 56 variation of a same model, different versions, but and different number of parameters. Now, very important for LLMs are, first thing when you look at an LLM, you have to look at how many parameters does LLM have.
Hello, Jitendra. Sorry
Yeah.
to interrupt you. It seems that your screen is stuck. And can you also screen share in presentation mode?
Sorry, just 1 minute. Yeah, can you see my screen?
Yeah, it's visible now.
Okay, so what I was explaining is that the first thing you have to do is to, in order to run an LLMs, to have a Hugging Face account. Okay. I'm sure many of you will have it, don't have it, just create an account is very easy. Because some of the models like Meta Llama will only be accessible once you have accepted their terms and conditions. Okay. There will be a lot of open source models that do not even need an account. I think you can just straight away go and use them. Okay. But some of the prominent ones like Llama, Gamma is from Google, Llama is from Meta, will make you to accept their terms and conditions, and Llama will actually take 1 day to even approve your uh, request. Okay. So, and say I want to search for Llama, so I actually did a search on Llama, and then I saw that there are multiple versions of Llama. Can you see that there? NVIDIA has its own Llama, Meta has its own Llama, and so on. And there are actually many variations of Llama. So what is happening is that once Meta has released their Llama models, like in the latest model is Llama 3.2. Yeah, 3.2. Other organizations can actually take that model. We call it foundation models. Okay, take their base foundation models and then also add on top of it their own training on top of it. For various reasons, various customizations, and that's what they can also come up with other versions of Llama. And their goal is to improve one aspect of Llama efficiency. Like they can make it better for Indian, like one organization in India called Sarvam AI. If you look at them, they are building a model which they're claiming that their model is better than Llama for Indian languages. So if you look at Sarvam, they have just released model called Sarvam 1. Okay, and this Sarvam 1, they are claiming that it is better for Indian languages, so it can actually understand Indian languages better than Llama itself. And actually they have not created this model from scratch. They have kind of taken the Llama 3.18 billion parameter model, and then they have done, or basically they have taken it 3.2, maybe it's 3.2, and they have kind of do some more training on it. Okay. So few things that you need to look at in LLMs is how many parameters do they have. So like 2.5 billion parameters. It is actually, in today's world, it is considered to be small language model. Okay. When we talk about large language model, their range will start from 70 billion parameter and above. Like Llama also has 450 billion parameter model. GPT, it's 4.0, has trillion parameter model, and so on. Okay. So although this is called LLM, but actually in today's world, now it should be called small language model, okay, with 2.5 billion parameters, but it can also do a lot of interesting things. 2.5 billion parameter can also do a lot of interesting things. Then second thing is you will see that it is using, so every model actually, you may know it's floating point numbers. It's just numbers. Okay, if you look at model architecture, is nothing but vectors and matrices and everything, which we studied in our linear algebra class, maybe in computer science or other curriculums like electronics, electricals, and so on. Okay, So what this is saying is it is using binary floating point number with 16-digit precision. Okay, 16 not precision, but 16 overall. It requires 16 bits to represent it, which is smaller than 32 bits for actual floating point number. And binary means that it is actually proposed by Google. BF16 is an invention of Google on conventional floating point numbers. The idea is to make the models more memory efficient. Okay, so when you load it in memory, it should need less RAM, less GPU memory, and it should be faster. That's the overall goal. Yeah. Now, how to run this? Okay, we'll come to that. But first, I was explaining like bit of this thing. Then, how to run a model? Basically, one thing you can always test a model just by in LLM, in Hugging Face, you will have a text box. You can always run a model there. Okay. Yeah. You can't see. Oh, sorry, there's something else. So let's see. I want to run MetaLlama 3.2 version 1B. I want to run it on my machine. Okay. This is what I was saying. You can go and chat upon it once upon a time. So if I give my story into it, which I was having it, let's see whether it is able to complete it. So my story was uh, yeah, this one. Yeah, let's see if it is able to complete it. Let's go to this. Let's go this. Let's see this. What happens? Can you see that it is started uh, completing the story? The tortoise, on the other hand, was determined to win and kept going and so on, right? If I just remove it again and do it again, let's see what happens. Okay, so as you can see that Hugging Face actually loading the model in its memory because probably it takes some time, but after a while it will share. So in the meantime, once it is completing, you can actually run this model in few ways. You can actually host it on Hugging Face, which will be a bit expensive. It will cost you something. You can also, you run this model on some free GPUs. Okay, so if you don't have GPU on your local machine, uh, there are few options you have that you also create an account on Kaggle. So Kaggle actually is a platform for machine learning engineers. But I think in today's world, it is also pretty useful for us security engineers too, because we want to test LLMs. Yeah. So one thing you do is you go an account, create an account on Kaggle, and then go to your settings. Probably then create a notebook, new notebook. Okay. So I'll say Meta Llama demo. Okay, demo. Then what you do is you go to settings, and one thing you have to do is you have to turn on the network. So this is one weird thing in Kaggle. By default, they do not allow network connection, internet connection, because of maybe security reasons. So once you turn on the network, probably first time you may have to register your mobile. So that's one thing you have to take care. Okay. Once it is there, then you see that it has few accelerators available. Okay. So few accelerators are like GPU T4. The first one option is GPU T4, which is a smaller GPU, but there are two GPUs in one shot you are getting. Then GPU P100. Okay, and I think it has 16 GB of video memory, and it has like 8 GB of video memory, but two GPUs are there. That's the difference. And third one is actually TPU, which comes from Google. So Google also has a GPU kind alternative called TPU, Tensor Processing Unit. And interestingly, Google's models are trained on TPUs. And in fact, NVIDIA's, in fact, Meta Llama, maybe first Llama was trained on TPU, because TPU is also a good alternative of NVIDIA. Only thing is, it is not yet commoditized, just like NVIDIA, GPUs. They are everywhere. On the other hand, TPU is just with Google. That's the only difference. So this is another option you have. Okay. So select this one, and it will actually turn on a instance with GPU, so that now you can start running your models. Okay. In the meantime, let's go to what has happened to our story. So can you see that this time it has actually generated a new, it has, it is again completing the text. Okay. So this is how, it works. Now let's run it on, let's run this on Kaggle. Now we will run not this version, probably we will run another version called instruct version. So what is happening is, if you look at these models, there will be two kind of versions of the models you will have. One is base version, and one is which are trained to answer your questions. We call it instruct version. So base version is nothing but, it just complete the sentence, and it is more versatile in nature. You can train it again and so many things. However, instruct model actually are trained to do question answer sessions, just like ChatGPT does. That's some small difference. Okay, so if you want to ask a question, I think it's better to run a instruct model. Okay. Now, in order to run an instruct model, I think there is a sample code you will see, and you can actually look at its homepage and see how does it work. Okay, so this is how actually you can run this model. This is simple code. You can copy paste also, and uh, if you run it on CPU, it's going to be quite slow. So let's run it on a GPU. So we are going to take this code, go to your notebook, clean this up, everything. You are now change the accelerator, and I will just start, running this. Okay. So what it is doing is, it is actually using some libraries. One is transformer library from Hugging Face, and transformer actually, Hugging Face provide a very good interface to run LLMs. It makes life very easy for us. Right, like in this case, we just have to use this pipeline library, provide the model ID. So this model ID will be, you can take it from, this model, just copy this. And so this is the model ID of Hugging Face. Okay, so you can take this model ID, copy paste here. Okay. Then there is a function called pipeline. And this is kind of a wrapper on top of more advanced functions, which we will take a look up later. But this is good to start with. For security testing, I think this is good to do. This is good enough for today. Okay. So you can see that we are telling it to be text generation. Okay, we are giving it that we are running a text generation model. We are giving the model ID. We are telling it to use B16 to be more memory efficient. And we are also telling it to be auto, which means select either GPU or TP or CPU as required. Or actually, it can even run on both. If you do not have enough GPU memory, it will also use some CPU computation too. Okay, that's all. Now let's see if it works. The few things we may change. Then you have to create a message for LLMs. So this is a message, format of a message, like role, system, and what is the content. So you are saying you are a pirate chatbot who always respond in pirate speak. You can change it to anything you want, like you are a responsible chatbot, or you can even remove it. It's not required to have a system message. So system message is nothing but is a prologue for a LLM. Then user content, which what question you want to ask. Okay, so you have to create the message in this format, and then just give it to this function called pipe, this object called pipe, and it should work. Okay, so let's run it, and then I'll tell you how to tweak it for your testing. Okay, let it run. In the meantime, let me also do one thing. So what it is doing is once you start running it, first of all, it will go and start instance with, as you can see, it is going to start a GPU. Okay, so there is a GPU available with the 16 GB memory. It also has a local instance, RAM and CPU and everything, which it used to download the LLMs. Okay, so you can see that we are getting an error right now. What it is saying that is restricted. Okay, so this model is, it is saying we cannot access this model because it is restricted. Okay. So what we have two options. One option is that we will use the Hugging Face token, or we will use some other model to run it. Like we can use to start with NVIDIA Llama model, Llama NVIDIA model, which may be free. Yeah, 3.1 Hectron HF. Let's see this one. So it is 17 billion parameters. So probably it may not work. Now we will try to see if there is any other model we can use. Or we will try to use first the first GPT-2 model, which was released in OpenAI community. Okay, so this is the basic model. You can try to use it. So in order to use it, again go to the code, and documentation. You will see, various things. So you just have to replace the model ID in this case. So we will just replace the model ID. Now I'll also tell you how to run a restricted model like MetaLlama later on. But first, let's do our work. Let's start using and at least run a model. Okay. So you can see that it is again giving an error, and this time it is cannot use template function and so many things, right? So the reason is that we are using template function, uh, cannot use a template function, which means, so most of the time what you have to do is you have to look at its code and find out how to run it. Okay, like in this case, it is very easy. I do not have to just have to do this. Okay, uh, yeah, this much. So that's what I wanted to show you, that just basic variations you have to do, right, in order to run a model. It may give an error sometime. So I just change few things, like rather than giving in a structured format like this, I'm directly giving a text, a query which I want to ask. Okay, and let's see if it works. Oh, so output is not defined. Yeah, sorry. Outputs. Let's see. So what has happened? Okay, so we will remove the number of sequences, and we will change it to say 100 max length. So these are the few parameters you need to take care, like how much of length. Sorry, let's do this. Let's see what is happening here. Yeah, so you can see that it is, this is the output of this. I'll just try to see if I can do this. Okay, so in this way, you should be able to run a model. Now, how will you start testing? I'll quickly just touch upon, or maybe we can have another session on it. Yeah, so this is the output of GPT-2. So this is the input text, and then it has started generating the output from here. Okay. In a similar way, I'll just you can actually take up another model and run it. Like last time I was running Servam AI model. So if you look at Servam, yeah, you can actually quickly replace this and start running the Servam AI. Now, before we conclude, I think I'll show you what are the security risks these LLMs can have. Okay, and maybe in the next section, probably we can start understanding how to even go and test. But before that, any questions? Any questions? I can take up. I think Anirudh have mentioned keep some time for questions. Because we have gone through maybe a bit faster, but I have this recording, so I may share it for your time. But let me have any questions. Huh? Any questions, guys? Okay, so should I ask some questions? Yeah. Yeah. So can you again explain encoder decoder? Yeah, great. So in encoder decoder, okay. So what we explained. So let me quickly show this slide. Yeah. I think the best way to understand encoder decoder is again look at this story. Okay. Where when I gave this story and ask you to complete it, what the first thing you did, you first go through this text and probably by looking at few interesting words like forest, rabbit, tortoise, slow tortoise, very important, and race, you understood what we are talking about. Probably that is good enough to tell you the context of what this text is about. Is about a story of, we all know tortoise and rabbit story. Then next step you did must be you read the story, and then after you understood what has happened so far, then you started generating the rest of the story by giving it your own words, by predicting the next word that should come here. Okay. In the similar way, our LLM works in the similar way. They have two parts. One part is called something called encoder, that actually kind of understand the context of your text which you have given by understanding, by doing some kind of correlation between different words it has. Okay. And convert this into something called embedding. So embedding is nothing but if I take an analogy from computers, just like compilers convert a high level C program into a binary code instructions, embedding is nothing but binary instruction for decoder. And your high level code is nothing but your text. This is the text. So it converts, encoder actually converts your text, this whole thing, into binary instruction, which is nothing but embeddings. And then this embedding go to your decoder. And then the goal of decoder is to actually generate and predict the next word one by one. Okay. So encoder understand the context and convert this into binary code embedding. We call it embedding. And decoder from this embedding start generating the next passage or next sentences that, if you combine both, should make the highest sense, or it should be highly probable, I would say. I mean, more technically, but in general, the whole thing should make more meaningful. Okay, so that's what encoder decoder does. And encoder decoder nothing but it's using actually those conventional machine learning models like neural networks and everything inside them. So interestingly, encoder decoder nothing but is a higher order machine learning model created from those neural networks that we have that we know from conventional machine learning. Okay. Any other questions? I hope I was clear. Yeah, thanks. Any other questions? Let me know.
Can you check the chart?
Chart,
The chat window.
chat window. Oh, acha. Okay. So, what are the other ways to run LLM model other than Hugging Face? Yeah, interesting. So, if you there are other ways to run LLMs. There's something called Grok. If you look at Grok, are you aware of Grok by any chance?
No.
No? Okay. So go to Grok. You have to register an account again. It is free, by the way. For now, it is free. So it's a good thing. If you go to Grok, then you go to Grok Cloud, I think. Grok Cloud. Okay. Grok Cloud, and you will get a Grok Studio. Okay. So you should be somewhere here. You should be somewhere here. Now this Grok also hosts many models. As you can see that, there are multiple models out there, 3.1, 3.1 versatile and so on. And you can also use it using API code. There is an API code also provided here. Okay. You have to generate a token and API code. And this is also a place where you can also play with and run, LLMs. Okay. Like you can choose LLM model.
How
Like,
about Olama?
I'm sorry, how to?
Olama.
Okay, so Olama is different. So Olama, you need to go to Olama and install it. So go to Olama. I'll maybe just finish this Grok first. Is it okay, right?
Yeah,
I'll
yeah.
finish the Grok because I just started, and then we will come to Olama. Just give me 1 minute. So in Grok, I think you can start using it just like this. We use Hugging Face. It is a studio where I can go and type my window. Like I can type provide the story of rabbit and right, so something like this. And if I just do that, it will probably understand what happens. Okay, so you can see that it has done it, and it is super fast. It's I think one of the fastest model you will see on internet. Its token speed is amazing actually. Okay, that is one. Second is if you want to run these things on your say CPU. So what happens is many times, one of the interesting use cases will happen is that you don't have high-end GPUs, right? And the challenge there is that how to now run these models on a low compute devices. But the research is still on, but there are few options such as Olama. Hmm? So what Olama does, it actually create a quantized version. Now this is a more technical word, but I think the more interesting thing is it is create a smaller version of the models that we have in the industry today, and then it provide them as a repository. So you can actually go and run it. And the way to run it is, I think you can go to instructions. It's Olama GitHub page, and they give a very nice instruction like how to install it. Okay, and then you can just run them. Yeah, you can, and then there are various versions available like Olama run 3.2, 3.2 version, and so on. So we cannot, okay, so we can also, so very easy to use, as you can see. We can also run it on the create example. Yeah. So this is the one example. Okay. Yeah. So Olama is also pretty easy on your local. This is the examples you can have.
I tried it on the
Mm-hmm.
terminal, but in my MacBook
Mm-hmm.
was like due to lack of power in GPU, so it was kind of slow. So then I used Docker in my Asus one, where I
Mm-hmm.
configured virtual sorry in the container. I just from this website, I guess, yeah, using the web UI I was able to
Mm-hmm.
get a web UI for that. And like Llama 3 I think I was using,
Yeah. Llama
and
3.1.
it was able
Which
to use my GPU for that. And
understood.
internet is not required to get the results. That was actually a good thing.
Uh-huh.
More like,
Interesting.
yeah, personal GPT kind of.
Personal GPT. Yeah. Yeah. That's very interesting. So you used on a Acer laptop, is it? Acer with
Asus,
GPU.
GPU was, yeah, 3050.
Okay, okay. So there was a small, yeah, very nice. I think that's so you can build your own. That's very interesting. And
Yeah.
what was the speed? Like, how was the speed? Can you
Uh,
share some to the
when I
audience?
was
Like,
trying
how was
in
the speed? Were you
MacBook,
happy?
yeah, when I was trying in MacBook, it took like 15 seconds,
Mm,
for each and
mm,
every, prompt I was giving, it was taking like 15 seconds to, return back the reply. And in Asus, like when GPU was there, dedicated
mm,
GPU was there, so it
mm.
took like 3 to 4 seconds maximum.
84 seconds.
Uh,
Yeah,
so that's
yeah,
that much of difference was there.
yeah, yeah. Yeah.
15
Only
seconds.
thing is, very nice.
Yeah, it's just 4 GP of GPU. If it's more like 8 or 12, something like that, I think even I can get the results more fastly, I guess.
Yeah, there will be two parameters you have to check. Number one is your prompt size. Basically, every model that you will run have a token per second response. So token per second is a standard way to measure the response of models. Okay, so it depends on two parameters. One is what is your input prompt and how large the output you want. So there are few parameters just want to go through. One is temperature, of course. I'll come later. One is max tokens, like how many tokens it can generate maximum. Unique tokens it can generate maximum. Okay. So if your input is small like this, then it is super fast. But if I say just copy paste the same thing and right, then now your input kind of goes into some 100 KB or something, isn't it? And then I'll say make the story bigger. Let's see what happens. So it took like 732 milliseconds this time. Okay. So it all depends on token per second. So I think in your case, whatever token per second speed you have got, if your prompt become larger, it will take more time. But very good. I think what you've done is very good. Maybe you can demonstrate it sometime in some maybe next session or something.
Yeah, yeah, it was just like a home lab setup kind of.
Yeah, great, great. I think how to set up a home lab and Anirudh, this is you have got your next maybe. Okay. So today I think we will not be able to cover too many things, but I wanted to first give a basic understanding of LLMs. Uh, Next step will be to even do a maybe we can take up a session, or you can suggest what next you want to take up. Like I want to take your ideas too. Like this was a basic session I wanted to give. Um, I have been giving sessions on LLM red teaming and so on, but sometimes those sessions are a bit advanced, right? So what all things you want to me to cover next time? Let me know. Just chat. Provide your you know this chat window.
There are
So
also a few questions in the chat.
yeah, yeah. So one question was, yeah, I'll just take up one by using LLM Studio. I think you've given it. Also, when use LLM API, does it download the model? Yes, it actually download the model. So as we saw, download model from some repository and place it in the machine. Yes, exactly. So as we saw, in this, for the first time when we ran, it actually was downloading it. Like I can rerun it again, stop session, and I will again kind of start this session. And you will see that it will download it and place it in your local repository. And then there is a specific directory, I think, in your home repository called .hf or Hugging Face slash model slash something. Okay, so you can find the model weights in your local directory. Yeah. So it will start, downloading this. So it is, once it comes, I'll come there. In reinforcement learning is different from transformer model. So reinforcement learning is actually is a technique uh, to train, in fact, to train models. And reinforcement learning is one of the techniques used to train LLMs from adversarial to make it more robust. Like in this example, it is downloading, by the way, just for your answering the question. So what it is doing, it is downloading all the weights like tokens and everything into one, and vocabulary. So it has a vocabulary, it is placing into a directory, and then everything starts. Okay. Now, so all of these models actually have gone through a training phase, this already, right? And the training phase actually work like this. Maybe at some place I'll have it. So this is, I think, the training phase. This is how it happens. Um, so what happens is that once you create a foundation models, like we saw the first foundation model of Llama 3.1. It's just the foundation model. It is a next word prediction model. And then we take that model and then convert it into either a classifier or maybe a personal assistant. Like we can ask a question just like ChatGPT. Okay. So when we make a personal assistant kind of model, just like we were using those instruct models we were using, right? Those are personal assistant models. We need to make sure that these personal assistants do not talk, uh, give up appropriate response when asked a question, right? So what is used today is something called a variant of reinforcement learning problem, where reinforcement learning is a reward, and reward is based on the rewards, okay, and examples. So this reinforcement learning actually is used to something called fine tuning, or something called model alignment, is a more technical word. During this stage, we use reinforcement learning as a technique to train personal assistants out from foundation models. Okay, so it is a technique, it's a machine learning technique, a training technique, to train transformer or LLMs. Just like you go to I think if you know already, Montessori is a technique to train kids. Conventional schooling is another technique to train kids, right? So Montessori or convention training is an example of reinforcement learning. Just like this, reinforcement learning is also a technique. Okay. Olama is like Docker for LLMs. Yeah, very nice. How does application team create wrapper around this LLM? Can you give a high level? Yes. So I have been using, LangChain for a long time, and it's pretty good. LangChain for building agentic apps. Okay. So if you go to LangChain and go to one of the basic tutorials, you will get to know how does it work. Or maybe at some point we can also have a session on build a chatbot from these models. Okay, so LangChain is one, and then Llama Index is another framework. Okay, most of the time I use LangChain, but a lot of people also use Llama Index for creating RAG and everything. But for myself, I think LangChain is good enough. It has a lot of things, including normal chatbots to frameworks to create agentic apps and so on. Okay. Yeah, so these are the topics, continuation, security, jailbreaks, explain what is adapter and what is the use case, what is LLM gateway. Thank you. Okay, good. What is adapter and what is the use case? Can someone explain, like, what is this question? It's a question, not a suggestion, isn't it? Other things, I'll take it up as a next session. Maybe we will stop today. But what is this question? Can you please explain so that I can answer if required? And we'll stop after this. Sorry, guys. Today is Sunday, and I know you have a lot of plans for yourself. And I'll give you a homework, maybe. Yeah, two things. Do you want to explain this question? I know your name is coming as Velocity Z, but you want to explain this question? What is adapter? What is the use cases? Adapter, I mean to say. Okay. Anyway.
I think he left the meeting.
Listen. Okay. No worries. Okay, so now let's come to the homework, or I would say the assignment maybe. So for the next time, what I want from all of you is to create a playbook just like this, to create a Kaggle playbook where you are able to run MetaLlama 3.2 instruct model. Okay, we were not able to run MetaLlama, right, for a reason that it was asking us to have an account and everything. So what you do is you should be able to run this example on your Kaggle notebook. Okay, that's the step, because once you have it, then we will go to the next step and do some kind of red teaming of llama, maybe in the next section. Okay. And the hint is that what you need to do is you need to kind of create an account, create some API keys. I think you can do some Googling, right? How to run private llama model with token on Hug, okay, on Kaggle. Okay, so you will get to know, right, with API key and everything. You'll search and find out. So the idea is to create an account, go to settings. There will be some access token. So you need to have that access token. Go to the Kaggle, and in setting, there is something called add-ons and secrets. So go to the secret, and here you are going to, just like this, you're going to attach the secret. You first have to create it and maybe attach it. You will also get a code like this. Okay, this is a code, to get the secret. Uh, so this is the code you need to get. Hugging Face secret. You need to paste the code in this and paste it here. So this is now the secret. Okay, and then probably you need to kind of do. You need to set up an environmental variables. Okay, so what you need to do is os dot environ maybe, and I think you hf token something like this you need to do. So what it will do is it will set up a environmental variable called hf token, and then once this environmental variable is there, your meta llama should be accessible. Okay, so you do this much, and once you are able to run meta llama on Kaggle maybe, um, okay, or any other environment, Olama is also good. I'm good with that Olama. This is the easiest way, I would say, because GPUs, otherwise cost you money. Correct. That's it, guys. Thanks a lot. Yeah, thank you. I kept it maybe easy for now, but we will have. Yeah, we will do it. I think if you do this much, I think we are good to go. I want to be more hands-on, and for that, you need to have maybe some setup to be done, right? Maybe okay. Yeah, thank you. Have a great day. Thank you. Once this recording is there, maybe I may give you. Okay, thanks, guys. Okay. Have a great day. Bye.
Bye bye.
Yeah, sure. Thank you. Okay.